Hi RX, this is lesson 3, thermoforming polymers. Okay, so thermoforming polymers are able to be reformed, able to be recycled and reused, okay, and that's because when they're heated up, the molecular structure isn't altered enough in order to form a strong bond between the molecules. So when you reapply heat to it, they will start to weaken, and therefore you're able to reshape and remold the item that you're using. Okay, so because of that, they can also be reheated up and melted down into brand new items or different sort of materials, so that makes them recyclable. So some examples of thermoforming polymers are acrylic. Now acrylic's one of the most used polymers in school. We'll use it in your project, and it has what's called excellent optical qualities. That means it allows light through it well, which makes it a perfect polymer for things like light casings, especially things like car lights. So it allows the light to flow without any distortion. Secondly, we've got HIPs. Now, high impact polystyrene. I don't mind, or you don't need to know the full length of the word, okay, the long version. As long as you've got the shortened one, that's fine. You just really need to know what it does and what it's good for. Okay, so HIPs is tough, and it says it's good impact resistance. Now that means that it can take a knock well, it won't crack, it's not brittle. Okay, so again, it's ideal for things like children's toys because they take a lot of wear and tear. Yogurt pots, because you don't want food split, you don't want the packets splitting. So again, if it takes a knock in the shopping trolley or in the shop, it's not going to crack open and and lose all of the goods. Okay, high density polythene. Now this is hard and stiff, okay, and it's got what's called excellent chemical resistance, which means that it won't sort of melt or distort if you put some sort of chemical within it. So like for instance a water bucket, you might put a cleaning product in it that may react to other plastics. This one has excellent chemical resistance, so it won't do that. So it's quite important, for things like water buckets or washing up buckets or anything like that, that they have this kind of property. Finally, PET. This is tough and durable, and most importantly, or for what it's used for, food safe and low cost. Okay, so it's used for drinks bottles and food packaging, which is ideal for the manufacturers because obviously it needs to be food safe, but also if it's low cost, it means that the profits and profit margins for food and food packaging, it's not wasted on the packaging, they're making more money from it. Okay, so those are your 4 thermoforming polymers. Now we're going to look at a video now on how items are moulded and set, and we're going to look at the particular one of vacuum forming. Okay, so you might want to get a pen and pencil to make some notes.
Sometimes taking a bath is a necessity, but soaking in today's sleek bathtubs can also be an experience in supreme luxury. Modern bathtubs look nothing like tubs of the Middle Ages or those wooden tubs we see in Western films. To achieve supreme comfort, the designer explores new shapes via computer and design software, tools which make for speedy review of various shapes. Then a model is produced. This one, produced on a 1/6 scale, is made of cardboard, but other models can be made of clay, polystyrene, or by stereolithography. Manufacturing begins with an acrylic sheet. It is heated to about 200 degrees centigrade with ceramic elements. The sheet becomes soft and malleable. So that it takes the form of the mold, thousands of tiny holes in the shell suction the sheet by vacuum. The mold must cool before it can be opened. Powerful ventilators blow air directly onto the mold, lowering the temperature to 77 degrees in 4 to 6 minutes. The ventilators are then withdrawn. Then the shell is easily removed from the mold, and that's because it weighs a mere 16 kilos. To make a tub in another shape, they change the mold. They put it in another acrylic sheet. It is heated on the ceramic and fiberglass mold. The little holes vacuum out air, and the job is done. At any rate, the molded acrylic sheet is not sturdy enough to be filled with water, so it must be reinforced with fiberglass. This is the fiberglass. Mixed with resin, it is blown onto the mold by a robotic unit. Stored in reservoirs, the resin is carried to the robot by pumps. Here it produces a chemical reaction between the fiberglass and the resin, which produces a reinforced shell. Laminating is one of the most important steps. With brush and roller, they eliminate all air bubbles which could weaken the tub. This makes the fiberglass resin adhere perfectly to the acrylic shell. The process requires 75 minutes. The shell is then transported to the milling department. The shell is now dry and hard. They can extract it manually, but here they use digitally controlled machines. The operation begins with the trimming of the edges of the bathtub. During this operation, the robot will also pierce openings for the drains, the whirlpool jets and the air jets, for the overflow as well as for ambiance light. The bathtub, almost completed, is now sent to another workshop. They can now install the pump, the piping, and the blower. These last operations are done manually. The pump is installed for the whirlpool system as well as the PVC pipes, whose joints have been hermetically sealed to prevent any leaks. Finally, to make sure that everything is functioning well, each bathtub undergoes a water test. Some 13 steps have elapsed, plus 3 to 5 hours of work depending on the tub being made. It almost invites you to climb in.
Okay, so on this slide you can see the process of vacuum forming. What I'd like to do is have a go at this and see if you can, from using the video, try and fill in as much as possible on this sheet. Okay, I mean, obviously if you can't print this out, but you can rewrite it and then see how many parts of it you can answer by using the video. Okay. Finally, the fact test. I've put on a little sort of fill in the blanks. I'd like you to see first of all if you can remember what they are before going through the PowerPoint again. See how many you can get without having to look at it, and then try and write them out fully with the correct missing words, please. Thank you very much.